In this tutorial, I'll show you how to write the terms of a sequence from a general term. The first question reads, write the first four terms of the sequence whose nth term or general term is given. So let's start with question A. We have a sub n is equal to 2n plus 5. We want the first four terms, so we'll write down a sub 1 is equal to 2 times 1 plus 5, a sub 2, 2 times 2 plus 5, and the rest should look like this. Now we'll evaluate each of these. The first one is 7, the next one is 9, 11, and 13. So the first four terms of this general term equation or infinite sequence is 7, 9, 11, and 13. Let's go ahead and do B. We have a sub 1 is equal to negative 1 to the power of 1 over 2 to the power of 1 plus 1, and the rest should look like this. Now let's go ahead and evaluate each of these. Starting with the first one, we have negative 1 to the power of 1. We have negative 1 in the numerator. And in the denominator, we have 2 to the power of 1. That's 2 plus 1. Therefore, a sub 1 is negative 1 over 3. Moving on to the next one, we have negative 1 to the power of 2. That's positive 1. And this should be a 2. 2 to the power of 2 is 4 plus 1. That's 5. This will be negative at the top, and at the bottom we have 2 to the power of 3. That's 8 plus 1, 9. And lastly, positive 1 at the top, and at the bottom, 2 to the power of 4 is 16, plus 1 is 17. In question number 2, they want us to find the first four terms of the sequence in which a sub 1 is equal to 3, and the general term is shown right here, 2 times a sub n minus 1 plus 5 for n is greater or equal to 2. So they want the first four terms. We'll find a sub 2 all the way to a sub 5. Now a recursion formula defines the nth term of a sequence as a function of the previous term. So keep that in mind. This is why we've written n minus 1. Let's start by finding a sub 2. A sub 2 is equal to 2 times the previous a, which in our case was 3, plus 5. That is equal to 6 plus 5, 11. So we have a sub 2, we'll use that for the next one. A sub 3 is equal to 2 times 11 plus 5, that's 22 plus 5 is 27. We'll use that now for a sub 4. 2 times 27 plus 5, and that is equal to 2 times 27 is 54 plus 5 is 59. A sub 5 is 2 times 59 plus 5, and that is equal to 123. Finally, in our last question, our general term looks like this, where we have 20 over n plus 1 and this exclamation mark. That exclamation mark is called a factorial, and what it simply means is, let's say we have 3 factorial. That's the same thing as saying 3 times 2 times 1. If you have 5 factorial, it's like saying 5 times 4 times 3 times 2 times 1, and so on. If you have 0 factorial, that's a special case. We just say it's equal to 1. So they want the first four terms of this sequence, and we can easily do that by saying a sub 1 is equal to 20 over 1 plus 1. That's 2. 2 factorial is 2 times 1. We'll evaluate that in a moment. A sub 2, 20 over 2 plus 3, 3 factorial is 3 times 2 times 1. And you can guess the rest because it's the same pattern. 4 times 3 times 2 times 1. And a sub 4 is 20 over 5 times 4 times 3 times 2 times 1. If you evaluate each of these, this one is easy. This one is 10. This is 20 over 6. Here we have 4 times 3 times 2, that's 24, so 20 over 24. And evaluating this, you should end up with a reduced fraction of 1 over 6. And there you have it. That is how to write the terms of any sequence from a general term.